Millions of Python objects, gigabytes of wasted RAM. All because of one hidden dictionary per instance. By default, every Python instance stores its attributes in a dictionary called dunderdict. That flexibility comes at a cost. Hash table overhead, load factor tracking, internal pointers. Add dunder slots to a class and Python eliminates that dictionary entirely. Attributes live at fixed memory offsets on the object, cutting per instance memory by 50% or more. Without slots, every attribute read goes through a dictionary hash lookup. With slots, Python resolves it at a fixed memory offset, measurably faster. This matters most at scale. Hundreds of thousands or millions of lightweight objects like sensor readings, game entities, or data pipeline records. Here is the trade-off. Dynamic attributes disappear completely. Assign any attribute not listed in dunder slots and you get an attribute error. Dunderdict is gone too. Libraries that rely on setting arbitrary attributes at runtime, for monkey patching or serialization, will break on slotted classes. Multiple inheritance is another pitfall. Each class defines its own slots independently. They do not merge across the hierarchy. If any parent omits dunder slots, Python silently re-enables dunderdict on every subclass instance. Your memory savings vanish with no error. Deep hierarchies require careful, deliberate slot coordination. Use dunder slots when you have millions of lightweight objects. Just know you are trading dynamic attributes and simple inheritance. Follow for more Python internals. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.